Ever thought of giving some kind of automation to your doorbell? Well, that's what we're gonna do today in this video by using a PIR sensor. This is the setup for the smart doorbell or a small experiment using a PIR sensor. So you can see the connections are being given. I'll be telling you in the circuit section, so don't worry about it. So I've kept the Arduino inside a box and buzzer is being connected over here. Hope you can see that. I've connected in the 11th pin. Well, I'll be explaining it again inside the simulation. So let's just run and see the results. So I'm gonna connect the USB to the laptop. I'm gonna check the results. So you can see it is switched on. Also on the side, open the serial monitor. Okay, so you can see that the buzzer is being activated. So over here you can see the motion has been detected and then it's been stopped. So basically, as I keep on giving motion, whenever it is being detected, it will come as motion detected and then stops after the motion has been stopped. So if I be still, there will be no motion detected as long as there is no motion. So basically, when an intruder comes to your door, you can see that the alarm gets in. So as I move the hand, you can see the PIR sensor detected it as a motion and gave the alarm. Okay, now let's just see the simulation of the smart doorbell that we're gonna build today. It's very simple actually. As you can see from here, the circuit is very easy. Only two components, the PIR sensor and the buzzer is there. But I'm sure many will be having a doubt regarding the PIR sensor and the IR sensor. Well, it's very simple. As you can see from the name, both have IR. So basically both works on the principle of infrared. But PIR is nothing but passive infrared. Alright, so one difference is that IR sensor is gonna emit radiations, infrared radiations, and then detect it when there is an object in front of it. But over here, the PIR sensor is not gonna emit infrared rays, but gonna only receive the infrared rays from the outside object. So basically, when there is a motion in the external surroundings, you can see the detection of the PIR sensor. Whereas in IR sensor, every single time as it's gonna emit IR rays, when there's an object in front of it, it's gonna give the signal. So that's why we're gonna use PIR over here and not an IR sensor. So the idea is that when there is a motion from your body, it actually emits IR rays. That is why it is very easy for us to read through a PIR sensor. So let us now see about the connections. It's very simple. So positive and then ground from the Arduino board is given over here, and from there you can see two wires are being connected so that you give power to the PIR sensor, and one wire from the PIR, which is the out wire or known as the signal wire, is connected to the second pin of the Arduino. Then the 11th pin is being connected to the positive side of the buzzer, and as usual the negative side is connected to the ground. So basically the value is input pin of 2 is going to be red, as the PIR sensor is going to give value to the code, and then from reading that value we can actually provide digital signals in the 11th pin. Okay, now let's see the code for this. So as I already said, the crux is the same. Just gonna read from the second pin and then write it in the 11th pin. So I've given all the values over here and all the pin modes over here. You can see the buzzer is the output and the PIR is your input. It's very obvious. So I'm gonna read from this line. I'm gonna read the PIR value, which is nothing but the second pin. So as I'm gonna read, if it is high, so basically it's gonna send high or low values. If it is high, it means it has detected some motion. So that time I'm gonna give motion detected. I'm gonna also have a variable called PIR state. So it's gonna be initially low. So when it is motion detected, at that second the PIR state should be changed to high. So that's what I've done here. So this tone function is very simple. It's just gonna used for your buzzer. So the buzzer is nothing but the second 11th pin. The 500 is your frequency and 50 is your delay time second. In simulation, it does not gonna make any difference. but in actual Arduino it will make a difference. You can play around with the frequency, you can see the high pitch and low pitch sound depending upon the frequency you give. So in the else part you can see as motion is detected, I told you the state becomes high, right? So when motion is stopped at that particular time it's going to be high, but then after that it has to be made low. So that's what I've made over here. So the code is very simple. The code will be given in the description as always. You can use it and run it in your project. Okay, so now let's just simulate and see the results. So if I start simulation, you can see that when I press the PIR sensor, you can see the range of the PIR sensor. So this is green dot means that the position of the object. So suppose if I change it, you can see that motion has been detected and you can see the buzzer sound coming up. So actually this will take some time for it to get stopped. Well, so when it gets stopped, you can see that all these messages coming up like motion detected, motion stopped whenever the motion is being stopped. The code will work perfectly as you have seen in the hardware section. So that's all for the video guys. Thanks for watching.